Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about underwater servers. So let's dive right into it. So first, exactly we have to understand why exactly there is a need for it. Well, increasing number of people that are using cloud, that is the biggest reason. Well, some surprisingly large amount of human population is now on cloud, and given this much population is there, almost this much is here, still we have a lot of people left. So that means there is a like almost exponential growth waiting to happen. So at this point in time, it's not a problem for us, it's a problem for future. So we have to start solving it today. Another aspect, the data on basically demands on data centers are going exponentially up. The more data center we build, the more things we do, the more metadata we create, the more IoT devices we add, it's growing exponentially. And one thing you have to understand, once you start to talk about like seriously large data center, power consumption of the computer, that's not that big of a deal, because again, you're getting paid for it. You take power, you compute, you make money. Awesome. Here's the deal. You're not getting paid for cooling power, basically. And cooling power on these sort of servers, large servers, data centers are so bad that they have a rating. As in, like, 1 means if your computers are consuming 10 megawatt, that's it. You're not consuming anything more. Even on Iceland, people are really getting more than that. What you are getting is like 1.4. What does that mean? That means if you're consuming 10 megawatts, you may be consuming 0.6, or like basically 6 megawatt. 100 megawatts, as in like 60 megawatts, would be consumed just for cooling, just for refrigeration, especially in hot climates. And if you are familiar with the fact that like India does not have that many data centers, that's the reason. The cooling cost here would be too high. Remove the electricity cost, the cooling cost alone would be brutal. So cooling power draw itself becomes a headache for every company, be it Amazon, be it Microsoft, be it Facebook. It's like they are paying a lot of money for the electricity, but they are paying boatload of money just to cool that electric resistive heater, which we call computer. So fundamentally, the more compute we do, the more heat we generate, more cooling is required. So somebody had an amazing idea. It's like, what if we take all of this and dunk it into a very large water body? Now, this is a critical aspect. This puppy will not work if we start to put this in ponds. It will dry up a pond very quickly. This will not work if we put it in a small river. A very large river, again, we are still tempting faith, given the fact that last year, people somehow managed to dry Francis River using nuclear power, because it was used as a coolant water and lot of cooling, and then water evaporated. So that was an issue. It needs a very large water body. What does that mean? That simply means generally sea or ocean. So basically, where you have enough water that it will not have any impact. Basically, water body that is large enough that can tame volcanoes, like oceans. Oceans have multiple volcanoes going in them, and ocean is like, I don't care, man. Like, our base temperature does not even go up. So that's what somebody thought. It's like, take this hot body, put it in a cool body, and enjoy. So why didn't we do it? What was the problem? Well, I'll tell you this amazing thing. Water is wet and hardware is hard. Hardware wants to be hard, it does not want to be wet. So these two things cannot get married. Even though they sound like they will be a good couple, they cannot. They need to be hard and separated. So that's the biggest issue, is like, you want to dunk it, how the heck you make sure that it does not get wet? And then you have to figure out, you need very deep water, meaning if you bury it like, let's say, only 1 meter or 2 meter, that's not that useful from thermal point of view, simply because a water's surface, as in like surface, is exposed to the air, is exposed to sunlight, meaning its temperature changes. As you start to go deep, let's say you start to cross 10 meters, 20 meters, at that point temperature is completely stable. But if you only bury it 1 meter or 2 meter, at that point in time, literally water temperature is changing based on day and night. So your servers are behaving exactly like they are behaving on the land. So to get any true usefulness, you have to bury them deep. Once you start to go deep, let's say 25 meter, 30 meter, deeper the better. At that point in time, it's like, yeah, I'm surrounded by ambient that will not change. So that's the whole thing. Another, power and data line needs to be pre-planned. It's not as easy as just like, here's a power line, here's a fiber line. These things have to be planned out very thoroughly beforehand. And thankfully, because of the development of internet and oil mining industries and all that jazz, and offshore wind farms, we have started to become really good and cheap at it. Hardware can't be accessed or serviced easily. Can it be serviced? Yeah. Well, they are generally planning for 2 years or 5 years service intervals, but you have to be like very mindful. Whereas, like, if something catastrophic happen, you may not have just luxury, hey, just go there and fix it. You may not have that luxury. Another problem that we have to deal with is biolife, meaning there are things, plant life, and the worst of all, barnacles. And those puppies, barnacles, they create cement. And those cements are good. How good? They can attach from organic life, like turtles to whales, to metal bodies like this, or even container ship that is moving or battleship that is moving. Like those barnacles are that brutal, and if it covers all of your surface, you will not have good thermal conduction from the outside. Basically, you are creating an insulator, cooking the hardware inside. So you have to be very mindful of that. And all of that has to be managed under a cost, very specific. At the end, I always specify you have physics, engineering, economics. Economics is the daddy. If economics is not there, you can do all above two, but it will not matter. So what is the economic margin here? Well, the margin is basically, let's say X is the amount of money you spend on the cooling hardware, the cooling towers, the water circuits, everything that you need. That's the X amount, plus the Y, that is continuous running cost of the basically energy bill that you have to pay. Take that, make that into Z, that you have to make sure that this whole system go inside that Z, or at least close enough to Z that over time this does not become, it's like, you know what, it would have been just easier to just build it on land. You have to be mindful of that. All of that has to be taken into consideration. That's why people have thought of that, and that's why like the old jokes were like, if we built a supercomputer powerful enough to match a human mind, it would need a river to cool it. People thought of that. It's just that water was like, yeah, not cost effective. So what about Microsoft? Now Microsoft created a project Natick. This was Microsoft's first try, basically that washing machine kind. It's much bigger than washing machine, look at that. That was their first try. And the idea with that puppy was, it's a design bed. It was like, what the hell we gonna do? It was not like, okay, this is what we're gonna mass produce. This is like, this is our attempt. Let's figure out things as they go. And the idea was they're gonna make, utilize commercial size pressure vessel, basically thick steel wall tubes that are just can be bought and purchased without too much hassle. And it was a proving ground. Basically, they built this and put it there, and it's like, okay, let's run the test. Let's utilize it as a, data dump servers and all that jazz to figure out, does it actually work? As it actually makes sense. And to improve the chances of survival, they drained the air from it and replaced it with nitrogen. The reason for that is nitrogen is dry, and if you do not have moisture, you do not have corrosion. If you do not have oxygen, you do not have oxidation. If those things literally extend the lifespan of the hardware that goes inside it. And everything was designed in such a way that is easily mass producible. For example, the diameter is specifically chosen that it can fit inside a standard shipping container. They're very mindful of that, that if you cannot ship it, it would be too expensive. So they're like, let's fit it inside a standard shipping container. So that's why like everything is like not that huge. And all the electronics that was placed in there, they knew for a fact that like no matter how good of a hardware you buy, like how high the mean time between failures is there will always be a failure. So everything that was put into the servers were designed what we call fail in place design. What does that mean? That simply means if, let's say, there is a 3 power supply that is acting as a redundant system, if one of them fails, it does not require to be pulled out. It's like, okay, I failed, done. I'm not gonna set off alarm. I'm just gonna create a flag, and it's like, okay, I'm done, and everything around me will isolate me, so everybody would be safe. And it's what we call safely fail in place. You do not need to pull it out. So sometimes that happens if power supply design is not very good. A bad power supply could cause harm to other products. So fail in place simply means, yeah, I failed, but don't worry, I will not take out everything else. I'm just like, I'm done. I cannot help you anymore. And all things should benefit you with free cooling. And C is a great hit thing because they put it there and they were very worried about it. It's like, given the fact that we have humanity as a species have the technology to drain rivers, so we were like very serious about it. Like, what about, like, we may not think, oh, it's only a few megawatts, what the hell is going to happen? But what if over long term is like, yeah, we dried oceans? So they were very serious about it. And again, on mathematics, they knew it will not happen because again, oceans have volcanoes under them, and that does not boil water. Let that sink in. There are actual volcano. You can be going on top of it on a boat and you will not notice there is a volcano under me. That's how strong ocean is. So this is just like nothing, bro. Like you have very few zeros in order to compete against a volcano. Then you have to exceed that to create any hassle. But they tested it and they're like, dude, even the best probes that we can do, best measurement we can do, it was like 1,000th of a degree Celsius increase. And again, that dissipated the moment you start to go far out. That's the whole point. Water is a very good conductor. So it dissipates a lot of heat very efficiently. So this was Microsoft's approach of getting that. They were the first company that was like making it big and going all in. Then we come to another company. I have linked their basically CEOs interview down below. It's a quite interesting watch. I would urge you to watch it. Subsea Cloud. And unfortunately, I could not find the actual footage of these things. They are just selling the CAD design at this point in time. But this company is something different. This company is like, I'm going to sell you berth on seafloor with all amenities that you need. For example, they will sort out all the power requirement, all the fiber requirements. Basically, what you need to run a server, we're going to provide. And we're going to provide you this box. You put your server racks in that puppy. And hardware will be your choice. However, it has to be all oil submerged. What Microsoft did is not oil submerged. That's why it cannot go very deep. This puppy is designed to be going deep, as in like so deep that there is no manned submarine that can go to there. Because you have to be mindful. In tomorrow's world, the most expensive thing for a country is data. So if somebody can access this puppy, that's bad. And you may be like, what about encryption or the hairstyle? If you have access to the physical hard drive, yeah, that data is already correct. Again, for normal you and me, it may be encrypted, so it's useless. But for pro people, that's like, yeah, it's minor inconvenience. So that's why there is a very strict rule by every country. It's like, dude, our data should not cross border. You're like, no, we have encryption, we have this. No. If data leaves, goes to other country, let's say data of America goes to China, it's theirs. Does not matter how many encryption layer you have, it's theirs only already. So this company was like, again, we are on international water, we may have some like, Russia going hululu. So in those sort of scenario, what if Russia directly tried to collect servers? Again, first of all, this is very deep. That's why this oil submerged is very deep. Another, there is a safety pin. If they try to pull it out, basically try to extract it, the pin will trigger a safety and boom, all the basically data will be wiped. And not to mention, it will be deep, like they're talking in kilometers, not meters, deep kilometers. So you cannot just go physically and just like, yoil, lol. And again, the CEO of this company, she's been working with oil fields. Basically, she was a RO, what do you call, remote submersible vehicle operator. So she already has experience with deep sea. And again, going very deep. So this whole system was designed in such a way that it has to be idiotically difficult for anyone to have access to this puppy. Like, it is so secure that a military grade basically data, basically weapons plan, defense secretaries, all that design stuff, basically things that people die over, those can be put here, and the likelihood of somebody is just going to lol it is very low. So that's a subsurface cloud system. And again, they're just offering you berth. You can store whatever the hell you want. Most likely pawn, but you get that point. So what we can expect in the future? Reality is tech is reaching maturity. And again, even China is doing this. What does maturity mean? Maturity simply means you no longer have the urge to constantly upgrading. Like, you're no longer in that loop where it's like, I have to buy new phone every 2 years. We all used to remember that. Back in the days, it was like every year there was such a big leap in mobile phone. It was like, whoa, oh my God, this is amazing. Now we are like, hey, this works. Or like most of the time we are just changing our hardware simply because A, software, or B, it's just like, the physical battery is like, war not, bro, I can't take you anymore. So at that point, it's like we have to retire it. So servers are reaching that point where it's like, yeah, you can buy the latest and greatest Threadripper or latest and greatest Epic processors. It's no longer like, whoa, it's like, bit better or all that jazz. So reach that point. So better uptime is now actually available. For example, the early days of Wi-Fi, everybody who had Wi-Fi, they had to restart the routers very rapidly. Technology was not mature enough, not stable enough. Routers had to be recycled constantly. It was like, oh, this did not work, this did not work. It took time. Now we do not even care about that. It's like, we have it, we don't think about it. That's how good it is. Servers are also reaching that. But back in the day, servers were like, hard drives were always failing, like a few hard drives per day. That was an average norm. But with SSDs, now we are like, yeah, that rarely happens. And all it has to do is last long enough for the service interval. Service interval could be 2 years or could be 5 years. And we have reached a point where we can do that. And fail in place server technologies are already there. For example, power supply that can safely go boom without causing too much hassle. And making all those technologies that have been developed parallelly, making subsea viable, meaning Microsoft can bury it and it will be actually useful. So Microsoft have shared the data of basically this puppy. And the reality was this was 8 times less likely to require maintenance, meaning they have already run this for 2 years. And all the data was like, hey, this is a good idea. That's why Microsoft went full ahead with this. And the reason for that is like, why this is better is simply because no oxygen, awesome. Fixed temperature, meaning if it's 30 degrees Celsius, that's it. It's not fluctuating, that's awesome. No human moving around. Humans generally move things and they bump into things and the fiber comes out and the hassle happens. That's also better. So it's a good tool for our future generation, where it's like, you know what, this is a good tool that we can deploy, at least reduce like, 4 megawatts of power consumption or 40 megawatts of power consumption in hypercluster. That is a good way of reducing carbon footprint. What about the ecosystem? Generally, it won't have any effect. Again, they tested it very thoroughly. Only issue is they have to keep it out, remove the barnacles again and again, depending if which location they are. Apparently, barnacles are like a sort of creature that moves around. You have to study its path. If you are away from its path, you may be safe. But I've never seen any old ship that has like hull that is clean. So I don't think that's that viable. But it's a good tool for us, like, whereas like rather than everybody creating Bitcoin miners in Iceland and melting all the glaciers, is like, bro, ocean is like, at least I can dilute that power much more efficiently. So that's the good tool for our future. So this was my presentation on basically underwater servers. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.